Hello, my name is Alan Boyer. I'm with ANA Technology Partner. I'm going to walk through a session here with Red Hat OpenShift deployment on VMware Workstation Pro. You may decide to use this for education, development, or just general review of Kubernetes itself. I will walk through the footprint, the pre-steps, and some of the post-steps you'll need for this to work. We chose this environment to give us a little better nuance of the OpenShift environment. We did review use of the open source version of OKD and compared it to OpenShift. And two items were a decision items that we decided to move forward with. One was that OpenShift provides a 60-day license that you can restart at any time to learn their environment. And the other one was they provide the Red Hat CoreOS with built-in ignition files, and they provided a SSH key that you build into an ISO image that does a lot of the heavy lifting. So due to that fact, we are leveraging OpenShift for our process here. So let me walk through the footprint here. So one of the strong prereqs that you do need to have involved is the DNS. Do not move forward without having this set up whether as a bind, or if you wish to, you can use a Synology device. There are 3 addresses that are required. Let me just show that information. So on the Red Hat OpenShift documentation site, they do list how to install on various cloud platforms, or bare metal, or ESX servers, VMware, vSphere servers as well. We selected install cluster on any platform just to give us a little better view into some of the details. And one of the sections, it talks about some of the DNS requirements that are required for the system. There's really 3 addresses that we needed for our methodology that we were going to deploy. One was the API and api-int, which is used for Kubernetes API server on port 6443, and a reserved route of star.apps, which is used by OpenShift for its applications. If you decide to deploy on one of the various other methodologies, you may also need to do a DNS for Bootstrap, control planes, as well as the worker nodes as well. And we've done that before as needed, but the methodology we chose, we only needed these to find. The other aspect you will need for a on-prem deployment of OpenShift is a front-end load balancer. We did select HAProxy, and you can see that down here in the lower right, and I'll walk through the configurations for that. And the heart of the solution, of course, is VMware Workstation Pro, acting as our data center with virtualized images, and we'll walk through some of the details on the specs for those. One of the post steps we did set up NFS mount point, so the monitoring and logging and any database or directory that you need to store data was retained. If you deploy on the cloud, you have many choices for storage classes. For on-prem, we just chose NFS. And we did use a Synology just both for the DNS configuration as well as NFS. And I'll just briefly show that as well. So for the DNS server, we have it set up with the star.apps, which is reserved with our domain name, and the api-int and API. So those minimal 3 were required just for OpenShift itself. You may need other addresses added for any applications you deploy on top of OpenShift. We did make this a little easier. We did choose it as CNAMEs for these and to point it to the HAProxy that we have defined out there as an A record, 2 different IP addresses. So I've got HAProxy actually configured twice on different IP addresses, and we'll walk through that. For the storage, just standard NFS is mounted out there, and we have that defined in our configuration files in Helm when we deploy it. And when we do it with OpenShift, we'll show that as a post step how we update OpenShift to use that as a general storage class for all pods that need to store data. And you can see data when it's stored, OpenShift monitoring, some directory data, some logging data is stored out there. All right, let's go back over here. The primary site that we'll be deploying on will be the console.redhat.com OpenShift. You'll need a developer's account. I do recommend you have a remote system that has an SSH terminal as the browsers and any other third-party UI tools that will be need to access any of the pods that are out there or containers that you have solution on. Once this entire solution is running, you will have a local OpenShift console that will have a lot more access out there. We'll review through some of the minimal binaries that you'll need deployed. You can deploy these anywhere on your workstation, laptop, OC, kubectl to manipulate the pods and the YAML files. You'll have Helm for projects that contain various components that you want to deploy. And for the VMware Workstation, we do need DHCP, so I will reset DHCP services to manage the IP addresses, so I don't need to go back and modify the HAProxy config, and I'll showcase that as well. So let's go to the console.redhat.com site. I've got that already listed here. Once you log in with a developer account, you can then select OpenShift. If it's a brand new system, it's going to ask you to create a cluster. We'll click on that right there. You're going to be offered three methodologies. You've got cloud, data center, and local. If I click on local, this is fine for some basic development, really small pods, containers on your workstation laptop. It's enough to just get you started to understand some of the OpenShift methodology and some of the security features. The cloud, you will see that Red Hat offers their own license there, but they don't offer the actual nodes themselves, the front load balancing configurations. Those are offered on other vendor sites such as AWS, Google's container platform, Azure, and such. So if you are deploying out in cloud per resource, and if you're doing a shared environment, that's fine as well. But if you're doing it per resource, reserve a budget about $500 a month for all the pods and other functionality. To lower our costs for training exercise development, we did choose the data center model, and I'll click that and show that. And you can see there's many different options they do provide. Some actually have ability to talk to the built-in API functionality and give you full stack automation. We selected the platform agnostic one. So I will start from there, and then I'll continue on some discussion about some of the detailed configurations, since this will take roughly 20 to 30 minutes to deploy. So we're going to pick platform agnostic, we'll do interactive, and to prevent myself from accidentally mistyping something, I'm just going to grab some of my strings up here. So again, we started with the open source model of OpenShift OKD, just kept the same name. There's no rhyme or reason for it to be that. It could be anything else. For your base domain, I do recommend that you have one registered so that you can build a Let's Encrypt cert, wildcard certs, to replace some of the self-signed certs. And the reason why that becomes important is when you expose this to external UIs, you don't want to have browsers prevent you from accessing the UIs or applications due to self-signed certs. OpenShift version, you'll see the major minor releases here. This is important depending on which applications will go on top of OpenShift. So I plan to deploy Semantics VIP Auth Hub, and this is the latest release. And you'll see under their recommended software requirements on specs, under Kubernetes, they do have OpenShift. And OpenShift 4.11 is currently supported with this latest release. So I will be selecting OpenShift 4.11. And again, don't worry about the last number, the build number, that'll constantly change. There's other functionality that I don't need. I will be doing DHCP using VMware Workstation. I don't need the static IP, so we'll skip this one. These are pre-built operators that Red Hat provides. There are quite a few other operators out there actually in their market space. I don't require these for VMware Workstation Pro. Host discovery, this is where the I would call it the magic happens, a lot of the work that Red Hat has done to streamline this process. Before I get into that, let me showcase the minimal hardware requirements. So they do list control planes at least 4 CPUs, 16 gig of RAM, 100 gig of disk space, workers at least 2, 8 gig of RAM, 100 gig of disk space. When you compare that to specs that your solution may need on the ones that you deploy after on OpenShift, you may need to adjust it. So in this case, OpenShift requires a minimum of 2 workers, but my solution actually requires 4 that I'll be deploying. And it does want 4 CPUs, but the RAM does match. So I will be bumping my specs up for that. And you do require a minimum of 3 control planes. That's a hard requirement by OpenShift to prevent any outage windows. So there's a minimum of 3 there. So let me show you the interesting thing here. So we'll add host. There's a full image here with Red Hat Core OS. You can do minimal. This is something a little brand new as of February 2023. And we'll do full image here. They do ask you to generate an SSH key so you can have access to the nodes after the fact. There is no user ID password. It is by the SSH key. So let's go ahead and generate an SSH key here. So I am going to go to, let me jump back out of this file. So I've got a couple files already. I'm just going to regenerate it just so you can see those being created. So let me remove those first. Alright, so they're gone. Let's generate brand new ones. Alright, got both new files. I catted out the public key one. I'm going to grab the first 2 strings. I don't need the third one. It doesn't hurt if you have it, but just need the first 2. I'm going to go back over here. I'm just going to paste this string in here. So now it's in. I'm going to create the ISO image, the discovery image. Once I click that, it will provide me with a wget command that I can now download this image. So copy that. I'm going to cd into a location that VMware Workstation Pro images have access to. There's the prior image. Let me just go ahead and remove that. So it's gone. We'll run through the wget. And while that's loading, let me show you my environment. We'll walk through that real quick. So here are my images. I've got 3 control planes defined. These have not been booted yet. I do recommend when you do create these, create at least one. Go ahead and just snapshot it before you even start it up. And then use the clone feature just to generate your control planes and working nodes. The only delta between a control plane and a working node is just the number of processors. So let me click on here so you can see it. So I just did 4 and 2. You can do it anyway. So I did meet the minimal specs of 16 gig RAM. I did bump it up a little bit because I did see an issue with one of my downstream pods when it was trying to start something on the control plane. So to avoid it, I just bumped the memory up a little bit. Hard drive space, it could be the SCSI or the NVMe type. Didn't really matter. And of course, NAT control, let it use that with the DHCP. The magic, of course, happens with this file here. So it's got the same path that I have down here. You can see that. Discovery _ image _ OKD, which is the environment name that I gave it, .iso. That matches there. The beautiful thing is when this reboots multiple times, I don't need to come back into this and disconnect the ISO file. It will know what state it is and ignore it. So I don't need to come back and modify these at all. So if I ever have any issues, I can do a rollback. I could click here and say go back to that prior state and repair my system if I need to. All right, so now we've got the brand new image. I've got this environment ready to go. The only thing I need to worry about is the DHCP. So let me show that. There's actually one thing I do want you to remove if you are using VMware Workstation. Let me grab that file here. Let me cap this one out first. So this was the prior values that were out there. There was one that was out there. I'm going to zero this file out so I can start off at 128 and continue all the way down. The configuration that I do need to have you remove if you use VMware Workstation Pro is the an option in the configuration file. So this is under VMware 8, the NAT address right here. So when you install VMware Pro, Workstation Pro on a Linux platform, this will be this location. And VMware Net 8 is the NAT location by default. So DHCP, DHCP.conf file. There's a section here called Do Not Modify. There's a default value here that's called option name, domain name, local domain. This actually causes issues for containers and pods when they try to do remote DNS lookup. For some strange reason, this value, when it gets added on, appended to a fully qualified name when it's going through its various resolutions, causes confusion for certain websites when you're setting up OpenID or SAML or the process. We don't need it. Kubernetes is going to set up the domain for us with the networking. This was just adding some confusion, so just go ahead and comment it out, or if you want, put your local domain in there, and your actual domain name, or just delete the line. Doesn't matter. So now we're going to zero out the lease file, so I've got the lines for that. So let me grab those. We'll paste that. So you can see the file was a certain size before. We stopped the network. We showed out the file just doing a cp command of dev null, 0 bytes. There's nothing in the file. Restart the network. Made sure that the NAT adapter restarted fine. A new size, and if we look at the file, it's just a comment field. It's just basically a banner in there. So now that file is completely empty. We're in a good state. We can actually start these images up. So if I go back over here, we'll close this UI. We're ready now to start up this system, and it will announce themselves. So let's do that. I'm going to start the first one. And you'll see it come up. It says Red Hat Core OS. I don't need to touch anything else, just let it boot. Just continually to boot. I'm going to move it over to the side a little bit, just so you can see it announce itself, and we'll be doing a few steps. After it announces itself, it will display a host name of its MAC address, and the role type will be unknown at that time. The role has a worker control plane as options, and also auto granting of a role. Since we're controlling this very carefully, we know which host will be our control planes and which will be our worker nodes. We will define the role as they do announce themselves. So over here on the console, you can see the IP address is 192.168.243.128. So 128 is the very first one. It's in the DHCP. It's grab that address. And you can see over on this page, it has announced itself. So auto sign, we're going to select control plane. And for the MAC address, just to prove to ourselves this is the correct box, if we right click on the image, go to settings, network adapter, let me pull that over a little bit, click advanced, and you can see the last three values here, 2A 4F90, 2A 4F90, so it does match. So we know what this is the correct image, which we knew since it was the only one we did boot. I did keep the host names fairly common nomenclature, the environment -cp-1 all the way through the same nomenclature. So we'll rename this, and that's done. And you may see the role show both control plane and worker. As soon as we add enough control planes and workers, this will be reassigned to just control plane. So let me start the next one up. And it usually takes about a minute and a half to about 2 minutes for each of these to start. So I've got 7 of them. So we're talking roughly about 15 minutes for that aspect. So while it's coming up, we'll take a look at the other configuration files. So let me go back to the overview. So we looked briefly on the Synology. We saw that we had the DNS setup. We saw we had NFS setup. We just did the rotation of the DHCP services. We generated an SSH key. I didn't show you the Etsy result, but it's just straightforward. Etsy, search the domain and just make sure that name server points to your wherever your DNS server is, whether if you're using just standard bind or if you're using Synology that's acting as your DNS server. We will download the binaries. I won't interrupt myself until we get a little closer, and I'll show you where to get those. And I definitely want to show the HAProxy, so let's make sure that we update and start these images, and we'll take a chance to review the configuration while these are starting. So, looks good. Let's start number 3. Alright, let's go take a look at HAProxy. And before I do that, let me just cat this file out again just so you can see it. So now I've already got 2 addresses in here for the 2 that did start. So HAProxy is our front-end load balancer. I did set a global variable to be the same IP range as VMware Workstation Pro's NAT interface. The rest of these values are fairly common for HAProxy. We'll go down here a little further. We did enable the embedded HAProxy stat page on port 9000. So if I go back out here on port 9000 for the IP address, you will see the 3 control planes being listed here. We're not doing anything with HTTP protocol. We're just doing standard TCP, just pass through. Once these are up and running, you'll see these turn green. So I'm listing on port 6443, which is used by Kubernetes API server, 22623 and 22624, which are used by the OpenShift for the ignition files. So let me go back over here. Let's change this to control plane, okd.cp-3. While this is starting up on the next one, let's start our first worker. I just want to show this real quick. Option-wise, if you make a mistake, you can click over here and change the host name if you maybe made a mistake. If you expand this, it's just really going to show you some basic information, what you have deployed out there, your primary hard drive, your bootable drive, your NIC and MAC address there as well. Down here at the very bottom, you'll see that view cluster events. If you click that, it'll show when you started and activity all the way until this cluster is completely available. So we'll close that. And if we watch the page as it goes by, if you want to watch the console, you can see this flip through several times. While it does have an IP address, the host name doesn't change until later when it actually starts deploying. You will see information about ignition files being introduced here. And right now we see it's been announced here. So we're going to set this one to worker now. And we're going to make this okd.w.1. And that matches the name that I had up here for my images. Start number 2. So allow that to come up. Once I have at least 2 workers from OpenShift's concerns, we've got the minimal needed. But we're going to go ahead and add the additional workers. So for the VIP Auth Hub, it only needs 4 workers. I plan to deploy more solutions, so I want to horizontally scale the solution. I'll create 7. Let's go back over here to HAProxy. So again, here's the API server port. If it comes in, it just redirects to one of the 3 control planes on the same port. And here's the IP addresses that are being assigned right now. And the same thing for the ignition files. It defines what what type it is, whether it's a worker or control plane, are listing on those ports as well. Fine. And we're just doing bind with no IP address, bind with no IP address, so it can listen on all NICs, and as well as that one. Now we had to get clever here on the binds here, and I'll walk through that. Let me just check my worker. Alright, so now we got 2 workers. You may notice the roles have been removed from control planes. So we got the minimal we need. We can click next, but we're actually going to add more. Let's add number 3. Let that come up. So one of the challenges we had is both OpenShift and other solutions want access to port 80 or 443 to offer their services. Since they will collide otherwise if we try to use a single HAProxy for this without this bind feature. And we would not be able to, we'd actually require 2 HAProxy configurations to manage the redirect. But we found by using this bind feature, we could actually redirect all the OpenShift requirements to port 80 or port 443 to these IP ranges for all the workers, or for our other application that will be on here talking to the worker nodes on port 80 and 443, where we're going to redirect these off this IP address to this node port. And we made this hard-coded in one of our Helm projects that we will be deploying. So 32080 for the 80 port will be redirected to one of these 7 workers, or port 443 to 32443 for these other node ports to these to the same workers. Let's go back over here. Let's start number 4. Alright, so that is the HAProxy configuration by leveraging the bind on the same network card. So let me exit out of here and showcase that briefly, what we did. So using this command, we can actually see what the IP addresses that are assigned to a network card. In this case, we have a 2 addresses here. We got the 101 and the 1.11. And you could also find this out by using just the IP command. You can see it as well. So here's the 101, and here's the 1.111. And you can see it has the nomenclature here of secondary port as well. Alright, so you can do it either way. And to add that secondary address, it's just a matter of just sudo into that network adapter and do a plus or minus if you want to add an address on there. Alright, let's change this. I'm just going to constantly jump back to the screen to keep this progressing. Okay, we got 1, 2, 3, and 4. That's all the minimal we need for the semantic solution. I'm going to go ahead and add additional ones. So I need to come back in here and change this. If you decide you need more workers after this deployment, once you come back into this console, you will need to regenerate a discovery ISO image. The certificates that are built into it are only good for 24 hours. It will not let you use the same ISO file. So just keep that in mind. So if you deploy it, if you don't deploy all the nodes you need, you just need to regenerate it again. Okay, so that's coming up. Let's go back to our main page here. The only thing we are missing that we didn't showcase yet was just download the binaries. It is actually on this page here. You'll see downloads right here. I don't want to change the screen yet, so I'll show that after the fact. So we should have number 5 listed here. So there's number 5. OKD.w.5. We'll do 2 more. So 1, 2, 3, 1, 2, 3, 4, 5. Let's start number 6. And go back to this page over here. I do have a page that shows those binaries, so let me show that real quick. So if you do click downloads, if you're on the console redhat.com, you can select the command line interface. This actually contains 2 binaries, the OC and kubectl. Just select Linux and download. If you hover over the download link, you will see the actual link to the latest and you can just run a curl command to grab it as well. We will need the Helm project, or if we're going to deploy the semantic VIP auth hub, or if you're going to do other solutions, you may want that one as well. So I do recommend that you download both of those. I can download those right now just to showcase it while we're waiting. So let's see, did we get the other node back? Yep. W.6, and we'll start the last one. Okay, this is our last node. I'm just going to move that over to the side. I'm going to go down to here. I have a window open where I'm root already. Let's remove the files that are in here. I'm going to just paste in these lines that I copied. And these lines were copied from the OpenShift browser. So we did a curl. I grabbed the Helm project, and I grabbed the OpenShift client. This one extracted the OC and kubectl, and that one extracted the Helm. I moved the OC binary to user bin. I moved the kubectl to user bin as well, and I've renamed Helm to, this longer name to just Helm under user local bin. Just a quick check to make sure that they are in the path and they do resolve. OC version shows me is 4.12, which is newer than what I have for the cluster. I have 4.11 for the cluster. It doesn't matter for the minor release if it's within a few iterations. Helm version 3.10, and kubectl version we see 1.21. Go ahead and ignore this message right here, as the cluster is not really up right now. There is no API server. But this proves that we can replace the binaries, update them anytime we need. And if you got it where it's always saying the latest, you can just keep running this and just constantly updating it through a cron tab if you want, or offline. Let's go back over here. We are done with the discovery. Now we're ready to advance to the next page. Again, if you made a mistake with the hostname entries, you can come over here and just change the hostname. We're ready to click next. Let's do that. Storage is just a quick check to make sure we got enough room. So the installation has plenty of room on there. It will reformat it as needed. Nothing to be done with the ISO, so we can click next now. This is important, the networking. We did choose VMware Workstation Pro, the NAT with DHCP. We don't need to set anything up here. We're going to choose User Managed Network. As long as we have our DHCP, our HA load balancer, the ports are not being blocked by our firewall, and the DNS is set up for those minimal of those 3 addresses, we should get back a ready status. So it's done some basic checking to make sure they can talk to all these host names. It has no issues. They can talk to the API server to move forward. And there's just, if you expand it, you just see additional detail about it. Again, for over here, if you want to rename it, you got one last chance. If you need to change anything. We plan to use the same SSH key that we defined on the ISO, and we're ready to go forward. So right now, just a quick check. The version, our domain, the number of cores and memory. If we go back over here to size deployment for the semantic VIP auth hub, we can see the number of CPUs it recommends and RAM. We're actually way above this. So it's saying 14 and 44. We've got over 52 and 178. So we are fine. All right, we're going to click Install Cluster. All right, it is now, let me pull over the VMware Plus image so you can see it. It will now be rebooting these systems and installing them. So the order it will do it in is, if we look over here, you're going to see one of the control planes was designated as a bootstrap node. So this one will bootstrap these 2 first. Once these 2 are up, you will then see these other ones, workers and the control plane itself being bootstrapped to itself. Off one of these to back to a control plane node. And usually this one should be last, if everything is fast. We should see the status bar advanced. Once it gets above 10%, we'll be able to download the Kubeconfig to actually talk to the API server. We can actually then check it for nodes, pods, and what's going on. Once it gets a little further, around 80%, we'll be able to be able to actually launch into the local console page. So not the console redhat.com, but the local console off our VMware Workstation Pro images. And it'll be talking through we can do it from our laptop, and it'll talk to the HAProxy and load the page up for us to the worker nodes. You will see abort installation until it is 100%, so just don't touch that one. You can click on View Cluster Events to see, again, when we started this effort until we actually have it completely deployed. Once the images are up and running, you'll see more pods running, being deployed. One of the post steps we want to do as soon as a single control plane is up is we want to enable Entropy. We did do a discovery while Red Hat CoreOS has the service, it does not start automatically when it is deployed via the ISO images, and it does impact the deployment of these components. So right now, you can see we've advanced over 10%. We now can download the Kubeconfig. Let me just click on that file. And I am going to open it. And you can see it. Let me close that old one. And you can see the cluster certificate authority has its built-in. The API.domain that I have set up on 6443, the admin user, and certificates that are in here. So I'm just going to copy this file, the text as is. I'm going to go over to my account. Remove the prior config. I'm just going to paste this information in from kubeconfig. Now I could set an environment variable that says kubeconfig that points to a different file if I want, but I'm the only one on this system, so let me change. I want to make sure it's standard security, make sure it's only accessible by myself. And to prove that it's working, I'm just going to do an OC get nodes. And since the API server is not up, it should not come back with anything, but it should not give me an error message saying config is missing. So this is a fine message where we are right now. So until these say ready, we don't have a single API server listing yet. Alright. So let's view cluster events. We can see that these are writing to disk, so now the images are being written. If we look at the console for VMware Workstation Pro, if you click through the links, you're going to see the host names eventually change. So right now they all still say localhost, so they have not progressed to even that step yet. And you'll see disk space being reformatted on some of these as well. Right, so none of them say the correct host name yet. So I'll move that over to the side. Let's take a look at our other pages here. So let me just briefly walk through the process until one of the control planes is ready for the Entropy. Again, there's three types. There's cloud, data center, local. We chose data center. We chose platform agnostic to go forward with. We had our DNS set up. So for the we use Synology, but you could use a standard bind. We have three addresses set up. We have API, we had api-int, and the wildcard, just for OpenShift. Nothing else was needed. For the HAProxy, we had the OpenShift configuration deployed. So here's the global settings. Just set a global entry, make sure we have the HAProxy defined here, and of course the IP ranges here. So we're controlling the DHCP what IPs were popping up. And we did set the bind here to be one IP address so we didn't collide with this other application over here. If you're not deploying a solution like that needs another separate ingress, you don't need this extra step. Let's go back and look. So everything's still just saying installing. Alright, let's go back to our deck. next step is just the type, just to reiterate. When you do build your VMware images, just choose Linux type as Red Hat Enterprise 8 64-bit. Since the ISO has Red Hat Core OS version 8, just make sure they do match as close as possible to ensure DHCP is working correctly. If you choose another Linux type, you may see it not bootstrap correctly. Increase your CPU as needed. 16 gig RAM seems adequate. I did bump it up a little higher just to avoid an issue I saw. You can use DHCP that's built into the NAT interface, or you can disable it and use your own DHCP service as well. There's something that's going to force you to do that. And of course, just build an SSH key for the ISO image. I do recommend you just build one and just use clone. Or you do a command line as well to clone it. I've done that before as well. So just little remarks. The type, the one image doing clone, 3 control plane nodes at least for OpenShift. The ISO is built by OpenShift. Update DHCP conf to remove that string so you don't have issues with on your containers and pods for reverse lookup. Reset your DHCP lease so you manage the IP addresses if you're not doing static. Insert your images when prompted. All right. The other aspect was, of course, in this local config, this is the before state. I just commented it on. I didn't change it. Downloading the binaries, OC, kubectl, Helm. And you can actually download these binaries in the local console as well. So it doesn't have to be in the console.redhat.com. Let's go over here and see how we're doing. Alright, so we've progressed to state 41. Still nothing's ready. Let's view cluster events. So right here it says waiting on control plane. So due to the entropy issues, we're going to see this happen quite a bit. So I want to showcase what the issue is with control planes with entropy. So before we enable the entropy pod, let me shell into one of these nodes. Let me shell into CP2. So let me grab that string. Okay, that's CP1. I'm going to CP2, which is 129. Okay, that one's not up yet, so let's go into the bootstrap node. So this is the bootstrap node, very first one. I'm going to showcase the entropy here. I'm going to emulate a password change for 1,000 times. If this was a system that had an entropy pump, the daemon was running, it would get it done in 4 seconds or less. So here you can see the entropy is going down to 44, 180, 116, 52, then it's down to here. So I only got through 67 password changes, and then it's just basically waiting on noise. I'm going to break out of it because I don't want to impact my installation. But you can see that it's running out of entropy quick. And since we're doing a lot of certs within this solution, self-signed certs, it needs the entropy to build for the security modules. Usually it's the bouncy castle libraries that are out there on Linux boxes. Let me exit out of here. Let's do OC get nodes again. And you can see now this proves that kubeconfig that I copied to the config file is working. It does see those nodes. They are just started. They're not ready yet, but they have just started. So after about 2 minutes or so, these should say ready. So what we can do here, we can do a little watch command and just let it run there, and we can see it as it goes by. And we can compare it to the UI here. So let me just shrink that a little bit. And we should see these say ready. Actually, we'll probably see it say ready over here first, and we do. And then eventually it'll say ready over here on the UI. So on the command line, we're ready to actually deploy. It happened like in less than a minute for each one. It hasn't reported itself here. Now to speed up this process, down here on one of the option pages I have to showcase it, after deploying everything, we're going to add entropy as soon as possible. This will speed up our deployment considerable. So you did see the entropy that was in the bootstrap. Let me show the entropy in CP2 there. Let me change this to 9. And you can see hostname, I'm in control plane 2. I'm going to paste in this same command line so we can see before and after. So before, I got to 39 before it ran out of entropy. So stop that. Let's actually deploy the entropy. So I'm going to go to, I've got a series of scripts that I've got ready. Let me cat this file out so you can see it first. So we're going to deploy a daemon-set of the HAProxy Entropy daemon, and we're going to declarations that are going to allow it to run on the control planes as well. I'm going to go ahead and delete and recreate it just to make sure it's available. In case it was there before, and we'll sleep and we'll grab the pods and check how it is. All right, so let me run it. And if you see a banner message this, you can set up a OpenShift SCC, secure context. If you do not set up a security context, OpenShift will create one in the restricted model for you as well. I didn't really need to create one, but you can take the time and actually do that as well. And that's another learning aspects that you'll gain when you get more involved in OpenShift. All right, let's go over here. We can see that about 53%, we see our control planes now say the word installed successfully. We now have the entropy daemons running. Let's go ahead and just watch for those. So git pod, we'll grab everything, rep minus I, HAPG. Right? I'm going to do a watch command for those. So until these are actually running, we're just fighting against entropy on the deployment. All right, let me shrink this a little bit so we can just keep it all on one screen here. And okay, those are now running, which is fantastic. So that should speed these up considerable. And now I want to show you what entropy looks like after these are running now. So let me go over here and click and actually do, let's do it minus O wide. And you can actually see which nodes that these are running on. And it should display CP2 and CP3. So right now it's talking, apparently it's talking to one of the, it might be talking to the bootstrap because it's taking a little time, and it should. Let's see if I can get it to talk to one of the other ones. Looks like it may be just a little busy. Let's do our jump back over to, so the CP2 where we saw it was really slow before. Let's rerun our little password change, 1,000 password change. It stopped before, I think it was like in the 40s or 60s. So now you've seen it zip through, there's over 1,000, and it did it in less than 4 seconds. So this makes a huge difference in deploying the pods and speeding them up. So right now we've got it deployed. Again, it's a daemon set. It's running on the control planes. It will run on the worker nodes as well. And as soon as the bootstrap is up, it will deploy it there. So get nodes. And we could do, let's do get pods, and we can see where they're, see if they're speeding up at all. Pod, wide. Let's do minus A for all namespaces. And the ones we don't really care about are the ones that say running with 1.1. So I'm just going to get rid of those. minus I, minus V, minus E, running. And let's say completed. And then we'll just watch it. Let's see. Alright, shrink this down a little bit, make it a little easier to read. Hopefully that shows through fairly well. So now we can see what's starting, where it's being started on. So here we see the worker nodes are getting deployed. CP2 and CP3 still have some activity. If you see one that says like installer with an error, don't worry about that. One thing's nice about the Kubernetes and OpenShift, if there's errors, they will constantly retry. And if it's a timeout issue during install, it'll time out and just kick off another pod to replace it. And if those still show up after we're complete, we can go back through the system and clean those up so they don't give us incorrect metrics there. Alright, now we're seeing everything progress there. Let me take a look at it from the UI. We're still seeing just installed green, these two. If we look at it from view cluster events, we can see those are installation stage, rebooting. And if we see where it says done like that, CP2's done, CP3's done, that makes a big difference. We should see done on the other one. Right here it says worker 1 is done. So if we go back and look at the UI, close this, we should see where it's green now. So let's see. Yep, worker 1 is now installed. Look at that. Alright, and another trick we can do, let's do Control-C, let's change this to not just pods, let's do nodes as well. The comma there. So now I'm getting which nodes are up and running. So we're seeing CP2, control plane 2, control plane 3, worker 1, worker 7 is almost up. You can see the IPs, what they are, that match what we had in DHCP. And if I go look at the stats report, you can see these are turning green now for control plane 1, control plane 2. We should see control plane 3. It's interesting it's showing it as right there. So that one must have just shut down just for a second on the API server. For the back end on 223, we can see that control plane 1 ignition is down, so it must be restarting it. Alright, so we see 1, 3, and 7. We see these are still, we removed all the ready ones that are coming up. Let's take a look over here. Still see just these 3. These other ones should be coming up fairly quickly. And we'll just keep an eye on this right here so you can see the behavior of the system. Just standard OC, get nodes, pods, just to keep an eye on it. You do see up here at the top of the pods, HAProxy, so the Entropy daemon is being created on the workers here. So once those are deployed as well, we'll see that speed up for number 7 and number 1. Looks like number 1 already had most of the minimal deployed. I've got this set for every 5 seconds, and I'm not seeing. If you see it pause for a little bit, then it just tells you that the one of the API servers is busy on the control planes. All right, we'll keep an eye on here. Take a look at the UI as well. And some of the other post steps, let me show those. So we're doing the entropy now. One of the other post steps, it takes a little longer, and I'll do it as a post step as well, is to replace the Let's Encrypt wildcard certs. And this may take anywhere from 10 minutes to 20 minutes to stop all the pods and regenerate them as well. So we've got a script that does that. I won't talk about how to do the Let's Encrypt, though that's a separate session. But we've got multiple domains in ours, and actually I can showcase the what we did to avoid some issues. So right here, let me grab this little chain here just so you can see it. While that's restarting. So paste this. So in the latest cert we have, under the full chain, you can see many of the wildcard certs. So we use those out on various cloud platforms, the AKS, Microsoft. We've got the short name there. We've got apps for OpenShift when we're doing IAM. Same thing for the OKD one as well. We've got the Google and Amazon listed, and some of the other apps that we've got here from SSP that were deployed out there. So we've covered our bases here with one cert, considerable out there. And just by using that one cert, we can roll it out every 2 months, and it'll automatically deploy it out there and have an issue with updating the cluster as well. And since we have 60-day cycle with OpenShift with their license, the 60-day and 2 months from Let's Encrypt overlap very well. Alright, so this is still going. We got 57%. It shows still 3 deployed. You probably saw that the API server was busy, didn't return anything. Now it looks like it's progressing again. We're getting data back. We're seeing, I guess there was one error with this one. It timed out, crash loop, which is fine. Just allow it to fix itself. And a lot of this crash loop it's the timing. It's the entropy is impacting it. So we're trying to get this entropy in there. If you don't deploy it, just let the system run for about 2 hours and it should be up. But to reduce it down to considerable, to half that time or a fraction of the time, go ahead and deploy entropy as part of the process. So now you can see it's deploying these out on all the other worker nodes. We can actually see, it looks like we've got 1, 2, 3, 4, 5, 6, 7. We've got all the worker nodes seen now. They're trying to get ready. The last one, of course, is going to be the bootstrap, because there's no way we can deploy a pod on the bootstrap until it becomes a control plane. So right here, it's a bootstrap before it becomes a control plane. So they won't have a pod on there besides what it already is pre-built. So we've got these 3 plus the one down here. Once all this, when all these are done, we still won't be 100% yet. We'll get up close to about 90%. We'll be able to launch into the local config page and see the other functionality that's there. And I usually wait till it's 100% before I do anything with the Let's Encrypt or add the storage class as well. There is a banner warning message here about the Kubeconfig file. They will allow you to download it for up to 20 days, but go ahead and download it. You can regenerate it through your local panel. If you make a mistake, you can build it from the system. But go ahead and keep it as a text file on your system just in case you have an issue. Alright, that is constantly going. Our first node was up for 15 minutes, 14. You can see how it's progressing there. Let's take a look at the console. We've got a few brand new pods being created there. Let's go down here, look at view cluster events. You can see here worker 7 does state it's done. Worker 1 states it's done. So by looking at further back on worker 7, you can see that installing for progress, 7.7 rebooting. So once you see those, you can see the lines, you'll know where the other ones are. So they're fairly close as well. Alright, let's close that. If I click on where it says installing, it doesn't really give you much information. If you click it here, you're going to see more information from either this, or if you're willing to go back over here and run the events command. So let me show you that. Let's put a W on there. So this is another way to get a little more detail about what's going on in your environment. You can actually watch all the activities going on. If you want to watch some more of the even under the covers for the APIs, you can put in a debug statement here, -v9, and you can get the actual APIs that are being called with the exact information. And you will see error message here if it's timing out or some reason happening. Those should disappear, so we can just do this. Get events. If it's restarting the API server or something, you'll see it just pause for a second. Or if it's talking to one of the boxes that didn't have Entropy defined, the HAProxy sent you to one of the control planes that was busy. Okay, see nothing there, so the API server is definitely busy. That's fine, it's just restarting. Alright, what do we got? Let's go back over here. Do we see anything yet? Nothing yet. Let's type our events again, just see if we see anything. And there's nothing to be concerned with right now. This is just the sausage making of rebooting the system, and they've made it very robust for any timing issues that are going on. Again, you just got to make sure your DNS is correct, that you can resolve host names. You need to make sure you have the DHCP services redirected. You need the load balancer in front. Without those, you're just going to have issues with deployment. Alright. Let's see what else. NFS share, we've got it predefined. We haven't configured the OpenShift to be utilizing that yet. And actually, while we're talking there, look, okay, the API server came back. Looks like every node's ready now. So CP1, 2, 3, W1, 2, 3, 4. So every node is ready. So it looks like it took. This was the last one, of course. 3 minutes. So about 20 minutes. Call it for all the nodes to be up. There's still pods being deployed. You still don't have the Entropy on all systems. You can see CP1 is now getting updates at the very end. If we go back and look at the console, we're seeing green everywhere. It's at 80%. Still says abort installation, so it's not complete. The options, you can't change the host name anymore, but you can look at the logs. We can click on View Cluster Events. You see done everywhere. And once the local console is running, we'll see a hyperlink listed here. And that should be after the 85, 90% once it starts popping up. So we see 3 control planes, we see 7 workers. From the nodes, we know all the nodes are ready. I can get rid of that just to streamline that. The only pieces we need are definitely the primary key value per data store. This has to be running. It's a very strong requirement. Otherwise, you'll have issues with Kubernetes. And the API server to host it, to service up the activity. So let me get rid of the nodes here just to streamline this a little bit. There, now we just look at the pods that are starting, that are not running and completed. So the only ones I really want to see is the installer ones that have errors. I want everything else to be gone. So we still see some activity in CP3, 2. I don't see any more workers. We'll see if those pop up. Let's go back over here to our banner page. Okay, we are now at 87%. We are now allowed to open the local console page and log in with kubeadmin and password. So it does provide those as well. So definitely store those information. We scroll to the bottom. Since we're not at 100%, we don't have. We still have the abort installation button. Let's try to log in to the URL. Let me click it. One thing you're going to notice is in both Firefox, Chrome, and other browsers, you will get this error message due to the self-signed certs and due to the configuration of this page is using HSTS security. So you cannot progress normally. Fortunately for us, Chrome has a workaround. If you type in the white space of the browser and type "this is unsafe" as one single word in lowercase, it will allow you to advance past this self-signed cert. So if I show you the certificate, it is a self-signed cert that it generated itself. And we will be replacing this cert with a Let's Encrypt cert. So let me just click over here in this white space, type in lowercase "this is unsafe." And what you may notice is the URL up there will change, and it should show me the next one. It's not completely up right now, so I'm just going to shut that down for a second. Wait till it gets a little further. Just because it listed it doesn't mean it's actually running. Alright, let's take a look at what pods we have. We still have a couple that are terminated or pending. This one needs to be fixed right here. Wait for that one to resolve itself. Waiting for this one to resolve itself for authentication. I'm not worried about these three. Alright, looks like it is restarting the API server from deployment. Let's do the events just to see what's going on. I'm going to look at the browser as well. So 87% here. And this should probably jump up fairly quickly once it restarts the API. This may be the last time. And if we look at it through the VMware console, you can actually see when it's restarting those boxes as it needs to. And you can see the host name has changed on all the images out here as well. Alright, we'll move that off to the side again. Alright, so we don't see any red here. We're seeing a lot of green, some sort of readiness probe to port 8443. Looks like something internal to the API server. Looks like it's doing some issues there. It's going to have to resolve that first to the OAuth. So it will probably, once it sees this type of behavior, if it's not connecting or issue, it'll restart it. All right. This is an interesting message about the number of pods there. So on the status page for HAProxy, I want to show this. So it's showing that the worker nodes are going through the for port 6443. We're seeing this port go through, the 222.633. We're seeing this port go through. One of the challenges, OpenShift only exposes 2 of the workers by default, doesn't have the other one. So we have to patch the system to be aware of these other ones as well. So that's another script here. Let me show that. Let me exit out of here. So we're going to patch the workers. Let me count that script just so you can see it. We're going to get how many workers that are out there right now, since we've got all 7 ready and working. It's going to just return an integer. We're going to patch the ingress operator and move it to replicas that, and then we'll just display it. So I'm going to go ahead and run that script. And you'll see this reflect. So before state, after state, it's going to update it. So if I go back over here to the HAProxy stats page, you should see all these red now turn to green, which it did. Alright, so that should be solid there. And it looks like that looks good there too. So the only thing that's failed right now are the installer ones. Let's take a look at the events. See if we see anything that looks like it's failing for any reason, and I doubt it. Let's see. Looks like it's good there. It's restarting some things. We see it over here. I don't see it there. Let's go into the browser and see where we're at. Still at 87%, not completely 100% yet. Yep, all we're seeing is that everything looks like it's starting up. Anything over here in the pods? Yep, we're seeing a couple pods pop up right there. Anything from the browser viewpoint? Let's take a look at here, view cluster events. Alright, so this is, you can see that this is one good message from the cluster events right here is how many pods was it deploying. So it's telling you that there was 804 pods for it to actually deploy out across the entire system. And there's containers inside the pods as well. But that's the numbers you're looking for. Okay, now it says it's completely. So it's saying this should be complete. So if we go out, close this, do we see 100% yet? 95. So let's see what the last message is when it comes up. So over here, look at that. Successfully fully installed release. Alright. Anything over here? No? No. Let's take a look at the browser again. Wait until it hits 95%. Or 100% there. We see installation here says complete. So that's now green. So all three of these are green. All checkboxes are green. So let's see what the final message is here. All masters are ready. No unhealthy members found, which is a good message. Looks good. Looks like it's starting another installer. Looks like it stopped the APA server on one box, and it's redeploying something on CP1. So it's fixing the ETC key value spare on the system. It has to make sure that they're completely in sync. Let that finish itself. Alright, we've got 100%. It's all check mark here. If we scroll to the bottom, you won't see on board anymore. It says launch the OpenShift console. If we look at the API, looks like everything's fixed. If it's not fixed, it will fix it. Alright, and the only thing we have as errors are the installers that don't really matter. Alright, let's go click on Launch OpenShift Console. So we click this. They do tell you, please make sure you've got these defined. Otherwise it won't work. Go ahead and launch it. Again, we see this message where we have a self-signed cert, which will not let us progress unless we do this is unsafe. And if we click the stats page, just to show that, everything's solid green here. The other solution that we will deploy later, we'll change these as well for that node port. Alright, so I'll wait for this page to display. And to make sure it's not a cookie issue, I'm just going to Alright, I was going to open it in private session, but I didn't need to. Alright, so now we got kubeadmin, a password, so let's go back over here. At the very top is the password. We'll just do copy and paste that in. And I'll click login. I'm going to store it in my password manager tool. And wait for it to display itself. Break out of that. Don't need that anymore. Now we're focused pretty much on the browser here. Okay, come on. I'm still doing that certificate. Right. I'm going to now wait for this to come up, and then I will rotate the Let's Encrypt certs. Let me open this into an in private session just to make sure it's not a cookie issue. Yep, that was a cookie issue. I just need to clean. I've had that browser open so many times. Alright, so this is the local console. If you click under workloads, you can click on pods, and it shows you all the running pods you have. If you click under home, under overview, you will get a quick little dashboard view of what's out there. And here's our, if I click on these three, they're down. All the installer ones, just clean it up. One thing that's nice about Kubernetes is if you delete a pod and it's part of a daemon-set or deployment, it will recreate it. These are ephemeral objects. They don't have any data in them that will be retained. So let's clean that up. So if I clean up, got all my nodes running, all my pods, good specs there. Any deployments, any deployment configs. Be careful of this up here. If you don't select it right, you won't see everything. Your secrets. One thing I do want to show is storage. So under storage right now, clean out of the box. There's no persistent volumes. There's no volume claims. There's no storage classes defined. So right now, even out of the box for OpenShift, for the Prometheus and logging and monitoring components, they can't store any of their login information. So we do have a script for that. So I do want to do Let's Encrypt, but it'll take a little longer. So let me just do these two right here. So let me cat that out just so you can see it. So what we plan to do, let me scroll up a little bit so you can see it. We're going to grab a Git that somebody's already set up for NFS. We plan to take it and CD into that for deploy. We're going to change the namespace that it has out of the box that's already pre-built, hard-coded. We're going to place it with our namespace. We're going to place the IP address with our NFS IP address of our Synology. We're going to place the path that it has with our path. And then we'll go ahead and apply the RBAC YAML. That's a part of it. That has just right here, we've placed it in just the namespace. We'll deploy an SCC. So again, make sure any service account can match this. We'll update the class file. We'll deploy the deployment. And we'll do some testing pods and everything. So let me run this one. And you should see the object class be created. So we always do a DevOps concept, delete anything prior, then recreate it. Again, if you don't create the proper SEC, OpenShift will just tell you a warning and make sure you're in the restricted mode. Alright, we're going to look at PVC claims, so it's coming up. If this works correctly and mounts correctly, a part of that project was it will, under this full path of the claim that it created, will create just a 0-byte file and prove it's there, and we'll clean it up. So if I jump back over to the UI, we now see under storage class NFS client. Under claims, we just have the test claim and the actual volume that the test claim is mapped to. So here's the pod that's tied to it. Alright, let's now deploy the second piece. This one updates the config map for all other objects that are on OpenShift. So we will update, make sure workload is enabled, because one of our components needs that. We'll make sure Prometheus, Alert Manager, State metrics, and these other metrics all are ready. And we've got sizes for them as well. And they all say NFS client. So we'll deploy those. And if we go back over here to the UI, if we click under the persistent volumes and claims, you'll see those start to be populated. So Alert Manager, Prometheus are all being populated. So in this state, you could claim that OpenShift is up and available. So just run it. You can deploy any solution you want on top of it. Now to avoid this not secure, I'm going to rotate the certs. That will take a little time. So right now it has been over an hour and 20 minutes of just the base deployment. Let me showcase the Let's Encrypt, and I will pause it to allow it to run, and then continue with the recording so you can actually see the after effect of it. So let's cat the file out. So there is quite a few documents on OpenShift, how to replace the certs out there for both the default ingress as well as the API server. There's other sites that had useful information to prepare. So we grab our cert. We have our wildcard certs already defined for it, which is a reference to the links that have been pulled down from Let's Encrypt. We will build a config map of the full chain and give it a nice useful name that we know it's the full chain, the config map. We will patch the cluster with the full chain so it has knowledge of it. Since this is Let's Encrypt, this isn't really required since it should be able to find the root certs, but this was, we want to stay consistent with methodology if we built our own self-signed certs with a trusted root cert, or if we're using an internal cert at a customer site. Build a secret with the full chain and the private key. Back up the English controller before, and then just go ahead and patch it. So now it's patched with this string here. Do the same thing for the API server. Build the Let's Encrypt for that one as well, in that namespace. See, the namespaces are different. One's OpenShift-ingress, one is OpenShift-config. And then we patch this one as well with the name of the API address as well as the Let's Encrypt cert, so they match. And then they just do some basic checks to see if they do return. So let's run this one. So it runs pretty quickly on the deployment, but you're going to see quite a few pods restart. So as a sanity check, OpenShift recommends that you watch the cluster operator of this system. And if you still see it saying progressing is equal to true, you don't want to change things. So write this is right now false, which is good. But now that we're going to rotate the search, this will change the true. We don't want to progress with any more deployments until this turns back to false. So let's do a watch of all the pods. Run that command again. So now you're going to see all the API servers, the OAuth, they're all going to be terminating and restarting with the new certificates. So you'll see a lot of activity right here. And it's another good thing that we did the Entropy Daemon, otherwise these would be slow to replace. So over here, you can now see it's progressing is now set to true. So we don't want to change anything else until this is complete. Alright, so let me just cancel that and get you the tech note real quick just so you can see it again. So let me scroll up. Let's grab this tech note, or the, not tech note, but the document. And I'll go ahead and run that watch command again. So we can always keep an eye on that. So replacing the default Ingress certificate under the security and compliance section. So it does mention you have that while insert for both the subdomain plus the .apps domain. So it helps to have these all defined. Talk again about the config map. You do have two equal signs here, just to be clear. This is defined. This is what your variable here. You will patch it, you will create your secret, and you will update the controller. Then when you do the API server, right down here, it's going to talk about the same thing about the subject alternative names for this. If you misplaced your kubeconfig file, this is a very handy way to get access to the API server to rebuild a config file. You just need to take out the prior certificate that was in your old one, or this new one if it doesn't match. So create your secret, go ahead and patch it. Then went to the fully qualified name here, so make sure it does match the API-domain name. And then you'll go ahead and update the cluster. One thing to keep in mind on is right here, step number 6. They do want you to watch this. When it is rolling it out, it'll be set to true. Do not continue to any other steps until this is false. Otherwise, you're just stepping on your toes. All right there. All right, so we will now let this progress. Let's restart all the API servers here. And it's now 1440 here. I'll go ahead and pause it until this comes back, or if there's something interesting we want to see. I want to show this error. So when you do rotate the certificates, you may get this 509 error, certificate signed by unknown authority, because you've rotated it. And this is due to that your kubeconfig still has the old certificate originally. So what we can do is break out of there, and you can just CD to that folder. Alright, and CP -RMSP. And we're going to remove the certificates in there. So just chunk it out. So I removed that section up there, so it should repick it right back up. So now if I do OC get nodes, we can now see the nodes being reported. Before I was getting that 509 error. So now I can see that, and I can see this message again. So I just want to call it that 509. When you do rotate the certificates, the certificate will be doesn't update that flat file. The kubeconfig, just got to replace it. All right. So these are still being restarted. This message is still true, so I'm going to put this on pause again until this does change. Okay, we now have the Kube API server reporting progress as false. The message had the various control planes going through different iterations and reported as they went through one node at one version, the other node at a different version, and finally they're all the same release. So progressing is now false, so we are good. So if we go look at all the pods that are running still out there, terminated, pending. So nothing that's really impacting us. Those are just correcting themselves. So the solution is up right now. All right. So let's go back out here to our consoles. Again, that we have the local console. We have an administrator section and a developer section. If you go through the developer section, you can do topology. You can click on various things. I'll tell you what's out there. Let's look at Kube systems, see what's out there. So the HAVG one there. If you have many different related type pods, I can show it there to you. Let's see what else. Yeah, just a lot of them out there. You can do observe. You can actually inspect what's going on in your systems. You can look at various builds, the helms you may have been deployed out there. If you do select on some of these, you can pull it up in the project there, and you get some of the secrets on config maps. If you go back to administrator, you can look at your nodes, what you have deployed there. You can drill into them, watch the specs there as well. The operators, if you need to install other operators, there is a marketplace of operators that you can deploy. A lot of pre-built ones. If you're looking at your networking, make sure you don't select. You keep changing this project out there, otherwise, the namespace, you could get yourself confused what you're looking at. Observe. There are certain things that OpenShift have a little alerts on, like they want you to set up alert receivers to make sure they are writing data out. If you go back to the main console for redhat.com, you don't really need to get anything else from here. You've already got the Kubeconfig, you got your ID and credentials. If you click back on clusters, you'll see it now listed as just a single cluster here. How many days that you got left on your license. If you decide to restart, you can archive it. Click drill into it. You can see some information. You got the Kubeconfig, view clusters. If you need to add additional hosts, you didn't add enough, you can click over here, add host, and go back through and create a brand new ISO like you normally would through here. Okay. Advisor. This is useful. This show you in case there's something that you've got misconfigured that it recognizes. So you can go through those steps. If you want to create some subscriptions or manage the cost once you get into a live production system, you can put those there as well. For downloads, let's show that. This is where that command line OC is, and the helm. And again, is if you change it to Linux and hover over here, in the lower left side, you actually see the hyperlink. If you have an issue getting into Kubeconfig or made a mistake, if you go back into the local console, if you can access it, and click over here, the question mark, you click on command line, you'll see copy login command. If you click this, you can do display token. You can do an OC login with that and grab your a copy of your Kubeconfig. Command line tools, again, like we said, you could grab the OC binary from the console redhat.com, or you can come into local, and they've got it listed here as well. It's the same. It's a slightly different hyperlink. Helm is there, and they got another tool here, Odo. So you are running. Don't have any metrics yet. We haven't deployed any other Prometheus or other functionality. But we have OpenShift running right now. Again, you can close down the main page. You don't need it anymore, unless you need to regenerate it every 60 days. If we look at the stats report for HAProxy, everything's solid green, except for my application. And let's see if that resolved itself. Yep, and that cookie in the main system did resolve itself. So I can get back in there. So again, my name is Alan Boyer with A&A Technology Partner. I want to thank you for joining me as we deployed OpenShift on VMware Workstation Pro. And I'll give you a view of the footprint before I close the session. DNS server with NFS mount point, DHCP via external, or it can be part of VMware Workstation Pro. Ensure the DNS is resolving correctly. Download the 3 binaries. A new SSH key. We showed that we could log in. And the HAProxy for the front loader. One of the other steps that we may do, real quick before I close the session, is let's set up OpenID. So if I go back to my system here, you'll see at the top you are logged in as a temporary administrator user. Please update the cluster OAuth configuration. So we'll go ahead and do that. I'm going to use OpenID. You can see there's quite a few options here. I have my OpenID configuration tied to Microsoft Azure, so I'm just going to set that up. Give it a name that will match the callback. Client ID, that's self-generated. Client secret, and the issuer URL. I don't plan to change the claim for username as default. I'm not going to change anything down here. Just going to click Add. And now the new identity provider has been added. It will take about 2 minutes for this to be updated. If I watch the pod, you can see OpenShift authentication does get terminated and restarted. And you'll see that bounced across all of them. So if I log out as this user, so I'm logged in right now as Kubeadmin. Let me log out. And back at the console page, right here, you can see the cert has been rotated to Let's Encrypt. Let me just show this while we're up here. So now I've got ANA partner.dev, and it's a Let's Encrypt cert. So that whole rotation worked successfully. I still got user ID password to log in. We don't want that, so I'm just going to refresh. And it should be after this is restarted here. So 17 seconds, we'll give it about a minute. Okay, looks like it started. Looks like that one's starting as well. And it probably should say, okay, DHCP 1 or 2 or 3 there. Let me go back over here and just click refresh and see if it's come back yet. Oh, and if you come back in here, there's this little caret here. Click on it, and you'll see the console again. Okay, let me close that one. So now that we've got OpenID, you'll see the user ID password login, and you also see the OpenID. So if I click on that one, it'll take me to Azure. And if I'm already authenticated, it'll let me in. And if I don't have access, so you see my name is up here now, I don't have access to anything. I'm in as a regular user. I can't get into user management, very limited access. Let me log back out and log in as Kubeadmin. And now if I go to user management, you will see my identity right there. And if I drill into it, on role bindings, I have user access. I don't have cluster admin. I can grant that access through create binding, but I also have a command line that already has that preset. So let me just grab that. Control C on that and just paste it. So now I've added myself cluster to row, cluster admin to my fully qualified name, or an email address that I've logged in with OpenID. Let's go back in. You can now see the cluster admin role is there. And if I log out and log back in, I can now see full access as my user. Again, thank you so much for joining us.